there. Okay, so my projectile motion example is that Eddie kicks a soccer ball with a velocity of 10 meters per second at an angle at 75 angles above the horizontal. How much time has passed once the ball has touched the ground? What is the horizontal displacement? So to solve this problem, the first thing you have to do is draw a picture. So I could draw Eddie, and then the path of the ball is obviously going to go up and come down, and then the soccer ball, and this is the triangle.
Wow, I don't have no more.
So what I have, this is gonna be the initial velocity horizontal, and this is gonna be initial velocity vertical, and the 10 meters per second is gonna go right here. To make it more explanatory, I'm just gonna draw out the triangle. And the angle is 75 degrees. So to make it easier, you have to separate your x and your y, and you write out what you have. Time, you don't need to put it because the time is gonna be the same. So okay, so we know that the distance that y travels is 0. We know that the acceleration is negative 9.8. That's always means, and the time we don't know. We do know that the acceleration for the horizontal is 0. Yeah, that's all we know pretty much. So now we solve to get the initial velocity of x and the initial velocity of y. We use sine and cosine. So you use so you do sine of 75 is equal to the initial of y times 10. So you multiply 10 and you get that the initial velocity of y is sine of 75 times 10, which is equal to 9.65 meters per second. And you do the same thing for the horizontal velocity, so it's cosine of 75, and you do it times 10 times 10, and that would be 2.58 meters per second. So you just write it out. Just write it over here and over here. And a shortcut we know obviously is that the final velocity would be negative 9.65 because it's just coming down. It's not accelerating, it's constant, so it's just going to be negative. So now to find, I want to know what's the distance traveled horizontally and the time. So what I could do is I have 4 pieces of information right here, so I could solve it. And the equation that I'm going to use is v final is equal to v initial plus acceleration times time. So to solve for time, I subtract v initial to get vf minus v initial is equal to a times t. So I divide by a, and I get that time is equal to vf minus vi times divided by acceleration. So I just plug in my information. Remember, this is the y part, so you use this side. So it's negative 9.65 minus 9.65 over negative 9.8. And the time is 1.96 seconds. So remember, the time is the same, so then I could do this over here too. And how I have now three pieces of information, I can now solve for the distance that was traveled horizontally. So the equation that I'm now gonna use is the distance, and I'm just putting the x so it connotes this side. B initial of x times time plus 1/2 acceleration x t squared. And how the acceleration, we know it's 0. We could just cancel that part out, and we're left with dx v initial times time. And now I could just plug in my numbers. So to get the distance, the initial velocity of the horizontal is 2.58, and I know the time, so 1.96. So the distance that was traveled horizontally is 5.05 meters per second. And my time is 9.6. That's how you solve the projectile motion.